Hey y'all, it's Sarah. I'm back with another L'Hopital's rule video as part of my Calculus 1 series. Today we're going to be talking about how to apply L'Hopital's rule to indeterminate products. So indeterminate products are when we have the limit of a product of two separate functions, and when we take this limit, we get 0 times infinity. Okay, so we have two options. Basically just depends which of the two functions we want to pick. But we pick one, we take its reciprocal, and we move it to the denominator. So instead of having g times h, we could have g over the reciprocal of h, or h over the reciprocal of g. And then we apply L'Hopital's rule until we get an answer that is not indeterminate. Now, for this first example, if we plug in 0 from the right, we have sine of 0 from the right times the natural log of 0 from the right. Well, sine, that's just gonna be 0, and then the natural log of 0 from the right is negative infinity. So this is 0 times negative infinity, same idea. So what I'm gonna do is I'm gonna pick sine as my function to take the reciprocal of because its reciprocal is defined as cosecant. And then from there, what we're going to do is plug in 0 from the right. We have ln of 0 from the right over cosecant of 0 from the right. And so that's going to be negative infinity over infinity. So now we can apply L'Hopital's rule. So the derivative of the natural log of x is just going to be 1 over x, and then the derivative of cosecant of x is going to be negative cosecant cotangent. So I'm going to go ahead and move the cosecant and cotangent to the top as sine and tangent, and then move the 1 over x to the bottom so that it's just x. So now we have negative sine of x times tangent of x over x. All right. And so now when I plug in 0 from the right, I forgot to write that, I have negative sine of 0 times tangent of 0 over 0, which gives us 0 over 0. Okay, so I need to L'Hopital this again. And so when I L'Hopital it, I'm going to have to use product rule on top. I'm going to get negative sine of x times secant squared x plus cosine of x tangent of x in the numerator. And then in the denominator, the x just becomes a 1. And so now if I plug in the 0 from the right, what I'm going to get is negative sine of 0 from the right times secant squared 0 from the right plus cosine 0 from the right times tangent 0 from the right. And that's going to come out to negative 0 times 1 squared plus 1 times 0. So that's negative 0, which is just 0. All right, so that's our first example. For our second example, we have the limit as x approaches infinity of x times sine of 1 over x. So if we plug in infinity here, we have infinity times sine of 1 over infinity. 1 over infinity is 0, so this is infinity times sine of 0. So that's infinity times 0. And so just like with the last problem, we need to pick one of these functions, either x or sine of 1 over x, to move to the bottom. I am going to choose to move the x. So this becomes the limit as x approaches infinity of sine of 1 over x over 1 over x. And so now when I plug in infinity, I have sine of 1 over infinity over 1 over infinity, 1 over infinity, like we said, is 0. So this is sine of 0 over 0, which is 0 over 0. So this is a form that we can actually L'Hopital. So now we're going to apply L'Hopital's rule. And so when we do that, the derivative of sine of 1 over x, we're going to have to use chain rule here. So the derivative of just sine is cosine. So we have cosine of 1 over x, and then we have to multiply that by the derivative of 1 over x, which is going to be negative 1 over x squared. And then on the bottom, we have the derivative of 1 over x, which is also negative 1 over x squared. For that, I just think of it as taking the derivative of x to the negative first power, and then you can just use power rule. All right. So now these cancel, and so all we have is the limit as x approaches infinity of cosine of 1 over x. So when I plug in infinity here, I'm going to get cosine of 1 over infinity. So that's cosine of 0, and cosine of 0 is just going to be 1. All right, next time I'll be talking about indeterminate powers, so stay tuned for that. Thank you all for watching. If you enjoyed this video, please like and subscribe.